Okay, so I think we should continue at this point. So maybe I will stop sharing my screen. And I suppose, Håvard, you're going to continue with the Git lesson, is that right?
Yes, I can take over for the parts about Git. So I'll start my screen share. And then hopefully everyone can see my browser window now. So what I am going to talk about is these 2 points here about version control and how we use Git and GitHub for our course. So over in the sidebar, we're under lesson 2 and then introduction to version control. So I'll start with just briefly about what version control is. And so here at the top, there's just there are 2 comics that probably you have been in the same situation before, at least I have, of being in a project and having multiple documents that are basically the same document, but just many versions and revisions of the same document, making the folder structure a mess. And one more way to kind of avoid that is by using version control, which we will talk about now. So version control is a way to track and store changes in the files that you're using, so that you keep a history of all the different changes that have been done to those files and documents. So in essence, version control systems, they start with having like a base version of the document you start with, and then save changes at each step of the way, that every time you do changes, those changes are tracked, and then it will keep a history. So you can always go back in time of your different versions of that document to restore and then start again. If the newest versions didn't work, you can go back to the old one and then start again. So it's a tool that kind of tracks those changes. And it, so there are some obvious reasons to use version control to kind of avoid what we saw in the 2 comics. And then there are many different types of version control systems. Like in Word documents and Google Docs, you have like these histories, and those where you can also go back and track the changes, and that's one kind of version control. But the one that is most commonly used in software and programming is called Git. And Git was actually developed by Linus Torvalds, who studied at the University of Helsinki. So he developed Git in 2005 to have a easy and better way to control versions of software. So in essence, Git takes kind of these small snapshots of your files each time we tell it to do so by committing changes. So and then you can also add descriptions of what has changed in those different snapshots, so that it is easy to see what changes has been done, both directly in the programs and scripts, but also described as well. And then, as you now are a bit familiar with, we are using GitHub, which is an online platform to use Git. So GitHub is Git on the web in a way. So it's a place where we can then host our Git repositories, and the repositories are kind of like the project structure of all the files that are in a project. So the Git repository is on is hosted on GitHub, and then we can take a copy of that and work on it, and then push that back to the GitHub, and then track the changes that have happened between those 2 points. Yes, you can read more in this on the website on this page, but I think that we are going to dive straight into how we use Git and GitHub in the course. So here under the Meet Git page, I will first go through a bit more about the key concepts, and then we'll jump into Jupyter Lab and then test out working with GitHub directly. So, yeah, the first diagram is trying to explain how Git works. In that, on the top we have the remote repository. So that is the files and folders that is stored on, in our case, on GitHub. Often we just say repo or repository. So you have that work in the cloud or on GitHub, and then what we do is we make a copy of that repository, or cloning, as it's also called. And then what Git Clone does is it takes the copy of the repository, downloads it onto your computer or on the Jupyter Lab on CSE notebooks, and then from that you can then do your changes, and then push those changes back to GitHub, and then those changes are reflected there. And so after you have cloned your repository down to your local machine, you can you pull and push to and from GitHub. So when you pull, you kind of check if there's any changes done on the GitHub repository, and if there are, then it downloads that to your computer, and then you can do your changes and push it back up. So then you have the latest updated version back on GitHub. So some of the advantages of this is that you keep a track of all the changes that you're doing, but also that this is a distributed version control system, so that there is one version on GitHub, and then you can multiple people you can work on multiple computers, and then all the changes can be done and pushed back to the main repository on GitHub. Yeah, so you can work. Multiple people can kind of work on the same project, and then those changes will be tracked in a convenient way. Okay, so as I touched upon, the version control system or the history consists of these snapshots of all the files in our projects. And the way that we record the changes to our files is that when we have cloned and our files down to our computer, in the working directory on the bottom of this figure, we can add them to a staging area. So we can tell the computer that tell Git that these are the files that we want to track the changes of now. So if you have multiple files that you're working on, but only 2 of them are finished and you want to push those, but you still have some other files that you don't want to add just yet, then you can add just the ones that you want to add, and then take those multiple files and commit it up to the repository. And then that will create a permanent snapshot of those changes that you made. Okay, I hope that was somewhat clear. If not, just either ask in the Zoom chat or make a reaction. But if not, then we are going to continue. So we're going to go through the basics of how we are using Git. So we will still be needing the Jupyter Lab instance, so keep that running. But what GitHub has recently made some changes. So before we could use the username and password when using Git towards GitHub, but now we are going to be using something that is called a personal access token. So we will be using that to be able to interact with GitHub from the Jupyter Lab. And here on the page, there are detailed instructions on each step, but I will also go through them, do them myself now. So, and I want, if you can, then it would be really good if you can do that at the same time with me. So in order to do that, we need to head over to our GitHub, head over to GitHub. So over here, we can then, if you're logged into GitHub, then we need to go into our settings. You find them on your user icon, and then down at settings. And then on the sidebar to the left, there is developer settings. And here there is an option to go into personal access tokens. So the personal access token is in a way just is like a password, but that is connected to your user account that allows you to identify with GitHub that you are using it. Yeah, so what I'm going to do now, we're going to head over to generate new token. I already have one set up, but we're also going to create a new one here. So we're just confirming that I'm the one who's doing that. And then here we are in the settings to create the access token. And first of all, we will give it a name so that we can recognize it. And then these access tokens, unlike your password, they will expire at some point. So that in order to not having to recreate them all the time, I am just going to set this to the end of the year so that we can use them for both these courses. And then we're going to have to give it some access rights or set the scopes for the access token. And what we need to do is give it access to work with our repos, which we'll be using. And then also the admin hook, repo hook, and delete repo. That's what we might need for now. So that's, after you've done that, you can click on generate token. All right, so what you see here is this is the token that you will be using. So what is important now is that you will only, as it says, you will only be able to see this once. So if you forget it, you will have to create a new one. So for now, we're going to copy it by clicking the copy button. And then I would recommend you to, just for now, open either a notepad or a Word document and paste it in there so that you can have it stored. I will later show you how you can store it on Jupyter Lab so you don't have to paste it all the time. But for now, keep it in hand so that you can use it when we start using Jupyter Lab. Yeah, and that's what we're going to do now. If you have that pasted in a text file or Word document or wherever, just keep it a little while more. And then we will head over to Jupyter Lab to start cloning our repository. And what I'll be doing is using the exercise 1 repository as the as to test out. So we will be doing this in the Jupyter Lab here with the Git plugin here. Yeah, so first here, going back to the file and folder structure on our Jupyter Lab instance, since we're going to be cloning an exercise, it will be nice to do it in the exercises folder. And so just when you're cloning, be aware which folder you're in, because that's where we'll be cloning and copying all the files to. All right, so I'm going into the exercises folder, and then in the Git plugin on the left, we can then clone a repository. That's what we're going to do. So when we click that, we see that, okay, we need the clone URI of the repository, and we can find that on GitHub. So since we're going to go to GitHub Geo-Python 2021, and then find our repository. Here you'll see the list of, you will just see your repositories. So you will go into the exercise 1 and then your username. So in order to find the URI to the repository, you can click the green code button, and then we can copy that. That is what we're going to need here, and we can paste that in here and press clone. And then we're asked for our username and password or personal access token, which we will be needing. And here you write your password and then find your personal access token that you have in your text file, and then copy that in here. And then we see that here, now I have a folder with the exercise 1 and my username, and here are all the files that were in my repository. All right, and I see someone who was not asked for password and token. So did you then get the files that you wanted for in that repository, and did you download your own exercise repository? If you can answer that in the chat, that would be nice. Okay. At least the important thing is that if you have gotten your exercise repo into Git, that's the most important thing. And then it seems that maybe your GitHub connection is already set up somehow. But there might be some instances that if you are cloning a public repository, you might not need the password, username or password. But if when you're cloning a private repository that not everyone has access to, you might need your username and token. So just make sure that you are downloading or cloning your own version of the exercise. Your own version of the exercise repository, and not the kind of template version that we have provided as well. because you will need to download your own in order to be able to upload it and get graded for it. All right, but it seems that most people are up to date. I can, so just make sure that you are logged into CSE and open up your Jupyter Lab, and then I can go through the cloning just once more. So here we have launched I'm using the same instance that we used for the Python tutorial that Dave just did. And then in my Jupyter Lab instance here, I used the Git plugin. All right, and now I'm already in Git in the repository, but here the Git and Clone repository, and then from my own exercise repository, go to the Geo-Python site and then get that, and then copy it here and clone that one. All right, and I already have that in my folders, so I can't clone it again. But okay, and I see that there's a question about the access token. So I can quickly go through it again, but also here on our course website are the detailed step-by-step instructions that I just did. So those are the same, but it's basically going in your GitHub settings, and then under developer settings, go to personal access tokens and generate new token. And then you will be shown the, I can set here, and then give the scopes, generate it, and you will be presented with this token here. So it's this part that is the token that we're going to need on Jupyter Lab to interact with Git. All right, and I'm not going to need that, so I'm deleting it. Okay, then we're back in Jupyter Lab. So what we have done is we have cloned our repository from GitHub, and now we have access to or we have a copy of the folders that were in the GitHub repository online. If we open we can see the README file. Here is that. So we get all the files and all the contents of those files. Yes, so using the Git plugin still, here we can see we are in the current repository. I'm in the exercise 1. I'm on the main branch, so we won't get into branches that much, as you won't be needing it for this course. But it's a way that you can basically make a copy, then work on it alongside the main branch, and then test out different features in that, and then get that pushed back into and merged into the main branch at some point. But we will just keep working on the main branch to make things a bit simple. Yeah, so here we can also see changes. We can see that we have not staged anything yet, and we have not changed anything. And then there's a untracked checkpoint file that we won't be using. Yeah, so what we will try to do is to make some changes to a file and see, and then try to push that back to GitHub. So I went to the file structure, opened the README file, and then we could add some self-assessment of how we did. So I think I did well on this exercise. If I spell that right, I'm not sure. But the important thing is here, we now see that Git has recognized that we have changed the file. So if we are just save that file with the changes, and now we can see that under changed here, the README file has popped up, which was indeed the file I just changed. So Git has now realized that we have changed the file, but it hasn't. We haven't told Git that we want to stage this and make it ready to go into GitHub again. In order to do that, we need to stage it. So that is the plus sign here. We can stage this change, so make it ready to, or tell Git that this needs to go up once we commit. Pressing that moves the README file into the stage tab. And we can also, if we realize, I needed to do something more, we can unstage it and then do further edits to the file. But at this point, I'm happy with it. We can stage it, which for those of you who are using the terminal, and we will get back to that later, it's the same as git add. So adding a file to the stage area. So the next thing we need to do in order to tell Git that we want this to take this snapshot of our files and push it to GitHub, we will make a commit. So and that is down here at the bottom of the plugin panel. We can write a summary or a title of this, and I can say added self-assessment, and we can also write further description if we did many changes or need to or want to describe it in more detail what we have done. But then if we're happy with our commit, we can press commit, and then it will pop up here who is committing, and then it is nice to give the name and an email, so that in the history we can then see who has done the changes to those at that snapshot or that commit. So we will add that. And then it is working, committing, and then we get committed changes in the bottom right corner. All right, so we've made a commit now, and if we go into the history, we can see here we have a commit, or we have those changes are on the in the history with the description that I put and the name I have, and we can also click and see more detailed information about this commit. All right, so if we then go back to the GitHub repository and try to refresh that, we see that nothing has changed because we have just committed it, but we haven't pushed the changes to GitHub. So in order for the repository on GitHub to be have those changes that we committed, we need to push them. So, and so we were going to push them, and a good rule of thumb before pushing is also to pull changes, just to see that if there's any changes on GitHub that has happened between what we have done and or between we downloaded and we want to upload it. So if we pull the changes here, we see that we, at least for me, I need to put in my credentials again, and which is, we can get the access token, copy in. Yes, and then we can, we successfully pulled, and there were no changes that have been made on GitHub. And then we can, if we are ready, we can then push our committed changes up to GitHub. And then this is, then I am asked for the credentials again. And if we then type that in and paste the access token, it will push it, and it has successfully pushed. So if we go to GitHub and refresh, we can now see there has been a commit up here with the description, and we can see that this file here, the README file, when the description here is updated, or it gets the description of the last commit, that there were changes to that file. So if we scroll down to the README file, we can indeed see here is the self-assessment I just wrote. Okay, so that is basically how to interact with Git and GitHub on the Jupyter Lab. But as you also saw, using the access token, it is a bit awkward to have to copy and paste, have a text document open all the time and copy and paste it. So what we can do to make Git remember our access token in our cache, we can use a few commands in the command line to make that happen. So the instructions for that are on our course webpage. If we scroll down to the push changes to GitHub, there is the note here where you can, which you can follow along to see that to use. So I'm just going to copy this this command and use that on Jupyter Lab. So in Jupyter Lab, I can open, if I go and open a terminal from the launcher, here I am in the terminal, and if I Control V, just on here, and have the command git. So this is, we're telling Git to do configuration, and these are, give the git command to interact with Git. It should do configuration, and these are global settings, and then credential helper, which will store our credentials. So just running this by pressing enter won't show anything, because what this does is it tells that Git that next time we provide credentials, it will store those credentials to Git. So I need to be in the directory that my Git repository is. So in the terminal, that is cd for change directory, and then type exercises, and then let me see the name. exercise and press tab to autocomplete. Right, so now I changed the directory of the terminal to the exercise repository folder on my Jupyter Lab. And I can just, if I press LS for list, I can list the files that are in that directory or folder. And I can see this is the Git repository that I was working on. So here, if I type git pull to see if there are any changes on GitHub, I am asked for the username and then press enter. I am asked for the password, or in fact token. So if I go to where I have my token, copy that, and then paste it. And every time the terminal asks you for a password, you won't see that you're typing, even though you're typing in, as a security measurement to not show your password. But once I have pasted my password with Control V and press enter, I get already up to date. So that means that my local version of my Git repository is the same as the one on GitHub. And now I won't have to type in my username and access token every time I need to pull and push to and from GitHub. Okay. I hope this made sense and that you are following along. All the things we have done with Git plugin, the cloning and staging, and that can also be done by going to the opening a terminal. So you can do that either from a new launcher, you will get this, and here you'll find terminal, or go to new terminal. Then that opens a terminal. And you can interact with Git. We can, if I'll go back to this one here, the Git plugin does the same things that is done in the Git command line. So to see here, I can write Git status, and I can see here I'm on the main branch. It's up to date, and there are no changed files, and so on. And if I want to further go back into my README file here and do some more changes, this was a fun exercise. Save that. If I then, you can see the Git plugin saw that, but I can also go Git status in the command or in the terminal, and we can see that here there are indeed, it has spotted that we have modified the README file. So in the same way that we here clicked stage, that is the same as typing git add and then add that file. README.md. And we can then again git status to see here there are changes to be committed. And if we want to actually commit it, we can type git commit and use the -m, which is a flag for message, and then type the same thing that we typed in the summary. So new update to README. And then that is a commit, and we can git push without having to type our username and access token. And indeed, here, if we go up here, we can see new updates to README. And here the changes are. Okay. So that was a quick run through of how we are using Git and GitHub in the course. I can see that there are some students who are having issues in the chat. But Dave is looking into that. So so if you're not able to do it all at the same time as I'm doing it, if you can fix the problems, that would of course be the best. But if not, we can also help you afterwards, after the in Slack and on the seminars as well. So I am going to proceed. Yes. So what we are on our so now we have used the JupyterLab Git plugin to pull and push changes from and to GitHub, and we have also done it from the terminal quite quickly. So the Git plugin is quite user-friendly and visual. So if you haven't interacted with Git and GitHub before, that is a good place to start. And you can basically do what is needed for this course. If you want to go into the terminal and want to get more experience with that, I also recommend that. If you use Git a lot, things get a little quicker and easier in the command line. But you can do, for this course, you can do everything in the GitHub plugin as well, or Git plugin here, if you want. Okay. Yeah, so if you want to dive more into that, I recommend going to our course web pages and going through the terminal sections with all the basics commands and resolving conflicts as well. Hopefully you won't experience that much, and we won't cover it in this lesson, but sometimes when people are editing the same files, or even one person has done one change to a file, for example, at the JupyterLab, and then on GitHub itself, then there might be some conflicts of that you're doing the same changes or slightly different changes to the same place in the same file. So there might you might stumble upon some conflicts. Hopefully you won't in our course, but if you do, Slack is the place to raise those questions about that. Okay, so now I'm going to head over to the using classroom for GitHub. So you have already experienced it with the first exercise that we've done. But just to make it clear what we're using the classroom for GitHub for, it's for your assignments. So we every week you will accept the assignment from GitHub Classroom, and then that will create a copy of the repository that is your private repository, where you do your changes to the problems and solve and answer those, and then push that back into GitHub to your private assignment, and that is the one that will be graded as well. But I guess I guess that is what I had listed for we talk about GitHub and Git for now. If there are any general questions about it, please let me know and type in the Zoom chat. If not, then I think I might hand it over to Dave. Unless I forgot something.
No, I think as far as I can tell, I mean, this part of the lesson's a little bit technically challenging. The first time when you get things set up, having to make this personal access token and having to clone the repository for the first time and put in your credentials and things. We know that this is something that's a little bit challenging. And of course, if you have questions, as Håvard has already mentioned, you can definitely let us know. I've been trying to keep up with the things in the chat a little bit, but for individual cases, if you're having problems, we do have the possibility to stay on a little bit after the class time ends and help you then, or you can also come to the work sessions or be online for the work sessions. This is one of the things that the course assistants can also help you with getting up and running with GitHub. So, but yeah, thanks, Håvard. I think that was a very good introduction to quite a bit of material with the version control concepts and Git and GitHub. And again, we are very much aware that this is not necessarily something that's super easy to just to take and run with right away. So I am going to.
But hopefully the point is to try to that we set it up once and then we don't have to do all these steps every week. That once we get it set up and everyone is up, has their access token set up and so on, then it will be easier every week to just do it.
Indeed. So what I'm going to do is, if there's not any urgent questions, and hopefully if there are, you can please put them in the chat and we will try to address them there. What I'm going to do is just point out a few other things on the course page and then walk us through the lesson, or the exercise rather, for this week, exercise number 2. One thing I don't think we had much time for last week and didn't spend that much time highlighting is that each week we have these GCP items. So these are good coding practice items. Last week there was one about good variable names. It just gives you some general information about how to choose the variable names that you're using. Might seem like a rather unimportant topic by itself, but it turns out it makes a big difference in how readable your code is. This week, our good coding practice is about describing your code. So it talks about how to add comments into your code. So these are lines in a Python cell, for instance, that don't actually do anything when the code runs, but helps you or other people who are looking at your code to understand what you have done. And of course, since we're using the Jupyter notebooks, there's also the possibility to have these Markdown Text cells where you can include things like nicely formatted text, tables, and other features in there to further describe what you're doing. For instance, if you're analyzing data from a data file. So the first question is, do I need to describe my code? This is mentioned in here. And if you scroll down, you can see a number of reasons why it's important to include comments and other things to describe your code. It's really can be a useful place for you to take your own notes so that you understand if you happen to be away for a week or something and come back to the code, you actually have some sense of what you were doing, because it's amazing how fast this just evaporates from your memory. And there's all kinds of opinions about this. So we are saying you should include comments in your code. If you go looking around on the internet, like anything, you can find a variety of opinions, including some people who say you shouldn't have any comments in your code because it just clutters up the code and makes it hard to read or whatever. When you're a new programmer, you definitely need to have comments in your code. And I would say even when you're an experienced programmer, you should be including comments in your code to make it clear to yourself and to others what your code does. So you can find some more details if you want to read through this part of the lessons from the course page. But the things I just want to point out here is you've probably already seen some examples of line comments in some of the Python cells. So if you start a line with the number sign or pound sign or hashtag thing, whatever you want to call that little character, it will, in Python, ignore anything on the same line that follows that character. So this comment here says this is a line comment. It will be ignored when this cell is run. If you were to run this cell in Jupyter Notebook, nothing would happen because essentially it would be seen as a cell with no information or no Python code in it. And so you can have examples of this where you have the comment above something that happens in your code, or you can also include comments later on in a line where you do something with the code, like print some statement out and have a comment following that. And you can also use this to comment out individual things. So if you've decided this line doesn't work, I'm just going to put the comment, put this number sign at the start of the line so that it gets ignored, then you can do that as well to kind of come back and fix it later. And yes, so another option are block comments. We'll come back to these more when we talk about functions in the week number 4. But block comments are places where maybe you want to have several lines of comments without having to have this number sign at the beginning of each line. So a block comment you can create by using triple quotes. So either 3 single quotes or 3 double quotes at the beginning will indicate the start of a block comment. And then everything, all of the text that is inside here until you encounter 3 more quotation marks will be ignored. So there is some output written to the screen in Jupyter Notebooks, but this doesn't actually execute any Python code in this situation. And so these are useful in cases where like you want to have several steps listed, for instance. So this is essentially how to become rich. And obviously we want to list each step on a separate line. And in this case, by putting it in these triple quotes, the block comment will then make sure that none of that code is actually executed, but it's rather just seen as notes for how to become a rich programmer. And finally, there's Markdown Text. These are in the Markdown cells, and you'll use this again next, or in this exercise for this week. So you can feel free to read a little bit here, but essentially the idea is that you can have bulleted lists, you can have links, you can have bold text, italics, lots of kind of rich text formatting inside of your notebook using Markdown, and we will practice with that this week. So that's our good coding practice for the week. I just wanted to note that here, and of course you're invited to read through the details on the course page. Now, I want to go through the exercise here briefly, but before I do that, I also want to say something about why we are working in pairs, because I know not everybody is fond of that idea, and I totally get it. I have had partners in life at various points that have not been the most enjoyable partner to work with when working in pairs on something, but we're doing this and we're doing it for a couple reasons. And I just want to say something here before we get to the exercise, because in this week's exercise, you will be asked to work in a pair. So part of the reason why we're doing this is that pair programming is actually something that is done, and it's part of an approach called agile software development. It's done as a method for developing code faster than individual programmers would write perhaps by themselves. So the concept is basically to have one person whose hands are on the keyboard. They're typing things into a Jupyter Notebook, for instance. They would be the driver in this analogy. And the other person is the navigator, who's basically looking over their shoulder, watching what they're typing in, and doing things like thinking about what the person who's typing in the code is doing, catching little typos that they might have if they've accidentally hit a quotation mark or typed in something incorrectly. The navigator is there to watch and to help guide the driver in that kind of situation. And this is very much like the kind of rally car analogy. So the driver in these kind of rally cars is helped out immensely by the navigator, who's telling them about the turns that are coming up, how fast and how sharp the turns are, how fast they can move around corners, and anything else, any other useful information the driver might need to know, because the information comes so quickly at the driver that the driver might not be able to process and react, especially going around things like blind corners. And so the navigator's role is sort of essential in maximizing the performance of this. And so by having these two in the car together, you're getting more than what either one of them could produce individually. And that's the basic idea with this kind of pair programming approach in general. So what we will do is we are going to, first off, create a list of all of the pairs. And then in that list, we will designate one person to be the driver each week for the exercises. And then the other person in the pair will be the navigator for that week. And you're going to alternate then each week in the course who is the driver and who is the navigator. The driver is going to be responsible for cloning the GitHub repository, so making a copy of the exercise using GitHub Classroom, and will be responsible for the version of the exercise that is going to be graded. So that means that, like, when you're working together, the driver would open up the exercise in Jupyter Notebook and share their screen so that you can watch and see what they're doing if you're the navigator, or if you're able to work in a way that's in line with the COVID restrictions, you could certainly do this in person as well, just both looking at the same computer screen. Driver's going to be typing in the Python and Markdown code. Navigator's going to be following along. And then the idea for the navigator is to be actively involved in suggesting ideas, noting corrections, and other kinds of things. The driver then makes different commits to the changes that have been made to the notebook, saves them to GitHub. And then the navigator can also remind the driver to do this periodically. And then once you're done, the driver should make sure the final version is pushed to GitHub so that that version can be graded. So what it means for the navigator is that you're trusting the driver to do this, and it's then your responsibility to make sure that that happens and that the exercise gets pushed, and you'll both then receive the same grade for that exercise when we do the grading. So we're hoping this is helpful. This helped, it seemed, last year for the students a bit, especially as we're still in a situation where we're doing a lot of remote work. This is very helpful, a very helpful process. So there's a question here in the chat about how do you know who is the driver and who's the navigator? We will let you know. We'll contact you in Slack or via email to inform you who is the driver and who is the navigator for each week, so that you know who is responsible and how to get in touch with that person. So yeah, that's the kind of pair programming idea. We tested it out last year and got some pretty good feedback. At least for the first few weeks, we will basically force you to work in a pair. And then I think starting in week 5, if you're really not into it, we can discuss possibilities of having people work individually if it works better for their situation. Yeah, so that's the basic pair programming idea. And if there's any other questions about that, please feel free to put them in chat. But given that we're running a little bit low on time and I want to just show you what the exercise is for this week, I'm going to maybe transition there. There is one question that just came. So is this pair programming used in real life too, or only in courses to support learning? No, I think this is actually something that came from Agile software development. So it was a practice that I don't know to what extent it's used, but it is definitely one of these practices that is used by real world developers of software. And it's been shown to produce better quality results more quickly. There's a question about whether 2 people working independently could produce more than the one set working in a pair, but in certain instances, it's very productive. And especially for new programmers, when you have a lot of uncertainty about syntax and uncertainty about what you're doing and how to proceed, how to approach a problem, it's really useful to be working together with someone you can talk to as you're working. And I think you'll see that you'll produce better results more quickly that way. So yes, it is a real world thing. So we're not just, it's not only for the teaching in this case. So yes, exercise 2, I think I have it here somewhere. Yes. So this is our exercise for this week. It's about lists and indices, no surprise there. And it's due a week from today, which is also probably not a surprise. So we have 3 problems in the exercise for this week, and they're already in a notebook that exists. So I will just walk you through that notebook quickly to give you a sense of what the exercise is all about. One thing to note here in this notebook is you're going to encounter cells that say something like this. It says your code here, and then there's this raise not implemented error. This should be deleted when you make modifications to the code. This not implemented error is basically just a way to show that you have not yet worked on one of the cells, but you should delete this and replace it with your code when you're working on the exercise. So just be aware of that. It's in the very top of the notebook as a note there to remind you. So the first question is about making and changing lists and using Git. So we have a table here, and you're asked to create a list of these station names and a list of the first years in which they were operating. And then once you've created that pair of lists, you then have an additional list that you should be then adding these stations to the earlier list that was already created. One word of, or one thing to note here in this notebook is we are looking at the notebook as you will receive it. So you can see, for instance, here, this not implemented error. You can just delete that. But when you're asked to create the lists here, we have supplied for you, for instance, some of the names of these lists, and we ask that you don't change the names of the lists because we are using an automated grading system that relies on these names of the lists being as they're listed here. Instead, what you can do is you can delete this text where it says none and put in your Python code for how you would create the lists that you're asked to create. To know whether or not you have successfully created the list, there are also these test cells underneath here. So once you make your lists, you can run that cell, and then you can run the test cells underneath here, and they will tell you whether or not you've created your lists correctly. So for instance, the station names list should have 5 items. If that condition is not true, when you run this cell, you'll get an error message that says the station names list should have 5 items. You can see here there are 5 station names, so that's what we're after with that. In addition, this checks to see that the first item in the list is Lighthouse for station names, or 2003 for the start years. And if you look here, it should be Lighthouse and 2003. So these test cells basically allow you to check and see whether you have the correct answer for this first part or for any of the parts of the exercise. You'll see them throughout. Again, here you've then got to modify your lists by adding some additional stations there, and then there's some more tests to see whether you've done that properly. You can then sort the lists using the way that we describe in the lesson, and then there is a test to see whether you've sorted your list properly. And then here we have an opportunity to answer a question. It's not worth any points, but it's just to think about what you've done and answer a question using Markdown here. And then there's an optional problem if you would like to learn how to use a function called zip. You can do that in part 5. Again, that's optional, and it's for no points in the problem. The second problem in here is about looking at 2 lists of months and corresponding temperatures, and then producing a bit of Python code that would allow someone to choose a month and say, for instance, have the code print out the average temperature in Helsinki in March is -1.0. So you can see here that we have March, we have a temperature of -1.0. So you want to be making a print statement that uses the information from what would be in 2 lists. So you're then given some instructions about how to proceed here. So you should define a variable that is the index value for which month you are interested in. Then you should have your lists of months and average temperatures. And then you should define a character string that is the print statement that you would print out when you run this code. So this cell underneath here, when you run it, will print out your print statement just to make sure it looks like it's formatted correctly. And again, there are some tests underneath here that will check to see whether your code is working properly. The third problem here is to practice using Markdown a little bit. So we were learning a little bit of Python language. You're also going to learn a little bit of how to use Markdown. And there's a nice link here at the top about formatting text in GitHub flavored Markdown. There are unfortunately several different types of Markdown. but we're using the kind of GitHub flavored Markdown. And so you can click that link to see how to use it. And there are a few questions about the exercise this week. What did you learn? What was unclear? And what would you change about the lesson? So then you have an opportunity to use Markdown to fill in your responses to those questions. And then lastly, you have the opportunity to add an image or basically include a picture inside of your notebook of a favorite animal. And so this could either be a picture you found online somewhere, or if you want a little bit more of a challenge, you could upload a picture to your GitHub repository and include the link to the picture inside of your notebook as instructed. So that's the plan for this week. That's our exercise number 2. I think all should be okay in terms of the links that are available to create a copy of the exercise. If you go to the exercise 2 page on the course page and you click on this link to accept the GitHub Classroom assignment, you will see something that pops up telling you that you can accept this assignment by clicking the green button, and it will make a repository called exercise 2 and then your GitHub username after that. There are also a few hints here if you're having some problems of some common issues. So you can refer back to the exercise 2 page to see the hints there. Are there any questions at this point? Seems like maybe not. So I will remind you of a couple things. First off, that yes, we are working in pairs this week for the exercise, but it will take us probably until tomorrow around lunchtime to send out the list of all the pairs. So please feel free to take a look at the exercise. If you're the navigator, it's totally fine to have a cloned copy of the exercise. We just won't grade it. So everyone can create their copy of the exercise the way they normally would. And then you'll find out tomorrow whether you're the driver this week or the navigator, and you'll then work with your partner to complete the exercise and turn that in. So yeah, unfortunately, it's a bit of a lag time to give us, or like to have us give you the list of who the navigators and drivers are, but we'll do that as soon as we can. We just need to spend some time this afternoon to create all the pairs, and then we can share that information with all of you. Otherwise, if there are problems with GitHub, if you're having issues with understanding the course environment and things like that, you're more than welcome to ask questions in Slack, or you can come to the exercise sessions. And actually, I'm realizing now that we didn't, I don't think, delete the, well, I don't know whether anyone has deleted the old responses for those who were going to attend the exercise sessions in person this week. I suspect we forgot to delete those. At least I forgot to delete them. And I don't know, Hofard, if you happen to have gone to the spreadsheet and deleted the old entries from last week.
No, I have not.
No. Yes, they're still the same. Okay, so we will clear those out right now. So if you have already signed up, thinking you signed up for this week, I'll try, if I see any that I recognize as new additions, to leave those there. But if you're going to attend the exercises in person, because we have the limitation on the number of people that can be in the classroom, it's currently set to 14 people. And so there's a limit then on how many students can join in to the exercise sessions in person, but they are still held as a hybrid thing online. So if you have questions and you're having issues with the course environment, please feel free to join the exercise sessions, whichever one fits your schedule, on Thursday or Friday this week. But yes, we have gone a little bit over our time. It's almost 12 o'clock now, and apologies for that. But if there aren't any urgent questions, I think that's it for today. And so we'll wish you good luck in working through the exercise for this week. Please feel free to join the exercise sessions, and we will see you back here at the same time for lesson number 3 next week on Wednesday. So we'll see you then.